testing, everyone's favorite topic, right? Right? It probably cannot be further from the truth, but it's one of my favorite topics and I will not skip it for this series. So just a quick overview of what we are going to cover. We will going to cover, of course, testing with circuit and testing presenter, testing producers, and how easy it is to do UI tests with this kind of a presenter and the state handling. Let's just go over the setup. So for the libraries, you just need this test one. I will close this one so you can see everything. So you just need this one and have it inside of this common test, implement it, and that's it. Now we can start with writing tests. First, we will see how to test presenters for state, and also you see that one of our events is go to other screen, so we will be also testing navigator alongside other regular state change events. First, let's just write a test to see if we have everything set up nicely. We'll do this. Okay, we can run it, and of course this is not going TDD way. It's easier to explain things when you are not going test first, but we will test, for example, initial should be 0. Counter presenter, fake navigator, counter screen. So this is the version of the navigator that we will use for testing. It has to be this fake navigator, and it stores everything. It has its own state, it stores everything, and you can later assert on it, peek, etc. So it will do everything that regular navigator does, just not navigating. And it's a fake, so it preserves information useful for testing. This is provided by circuit. And then there is this nice helper function that's test. If you are familiar with testing flows with turbine, then you know how this works. And this is exactly what it is under the hood. So this test is an extension function on presenter. It takes a block and how it is being created. So it's using molecule flow, and molecule collects all state changes within compose and emits them as flow events. So this is just wrapping it. It's also immediate, so it will start immediately, so it will behave as a hot flow. And as you can see, as a circuit receive turbine, it will after all of this, it will create a turbine. It is a receive turbine. This is, and yeah, if you've done testing with turbine, this is exactly the same. You await items, and you can see that this await item is calling things inside of it's await item on turbine, so it's exactly the same. And we will do assert equals. We said it should be 0. Let's see, count. Let's run it. Okay, it passes. Let's just see it fail first, and then we'll pass it. Okay, nice. I will just copy paste this and we will refactor things as we go. By 1, and then we would do await item. You call events like regularly when you are building UI, so we will call event sync, and we will pass events to it. And then we would, let's first see it fail. We know it will be 1, but yes, it fails. And then, yes, it's 1. And let's now refactor things a bit. This will, let's just extract it. It will be a navigator, and this would be a method, would be presenter. I like to put these on top, so just so we can have it. Let's pass it as a parameter named navigator, and because we will need to use it afterwards, we will have private val navigator. Oh no, let's deal with that later. Inline expression body, just so we can see it, and it will be a fake. Yes, exactly like this. So it will be fake navigator with counter screen. Okay, also here we don't need this. Here, let's see if everything works after our refactor. Yeah, everything works fine. Now we will do the same thing for decrement. Let's first see it fail. And yes, if we see it's expecting 1, but it's -1, yeah. And we know that it should be -1 because the initial one is 0. The third one that we will test is this one. If we have navigation wired up correctly, navigates to other screen. Okay, and we will not do this, but assert equals other screen. We would have count 0, and we would have navigator. Navigator await next screen. So it works, and let's just see it fail. Yeah, it fails, and yeah, that's it. And we covered unit tests for this state, and this is presenter state. Now I mentioned a producer. Let's first see what is a producer and how we can write tests for it. This is one of my apps that I'm using Circuit for, and as you can see, it has City 1, City 2. What is the app? There is board game, Seven Wonders Duel, and I made the app that you can score duel and game easily. You just take photos of each city. At the end, I have a helpful overlay here, and then you can crop it, do whatever, and then you can see we have City 1, City 2. We can change the name, well, this, and then we score it, and I have some custom machine learning trained model for this, but that's not important. As you can see, now it will score the things, but that's actually not important. What is important is that you can see we have City 1 and City 2, though both of these are doing basically the same thing, in just 4 different cities, and it needs to handle loading, a success state, error state. It has to keep track of the name, etc. And this is the cities presenter that holds the state for both cities and the whole screen. And as you can see, it has 2 state producers, City 1 state producer and City 2 state producers, and it basically only delegates things to it. I need to clean this up, but I made it testable by having get resources injected, but again, need to refactor this. But that doesn't matter right now. As you can see, it has city1 state and city2 state, produced by city1 state producer and city2 state producers, and then we are just using that in final state when we are creating. So its state is city1 state, city2 state, and event sync. Okay, city state producer is where things get interesting. As you can see, it also has a present function, but it doesn't extend presenter. We just created composable present with city state. Here it is. As you can see, it is circuit UI state. We have event like for the presenter, it's a circuit UI event, but it's not extending a presenter, it's just a producer. And imagine if we had, you see, it has name, it keeps track of the focus of that text field, flag or trigger for taking photos, it has a photo, military points, it has errors. So imagine if in a presenter we had this but times 2, city1 name, city2 name, city1 name focus, city2 name focus, etc. So it's a nice way to split things up. It is also recommended in recipes if you take a look at the circuit website. But how do we actually test this producer? In my case, it is actually tested as a part of city's presenter, and as you can see, I'm also using just presenter.test. But if I wanted to test it on its own, then let me just create a test really quickly. So here we have the test. For creating a producer, so we have city state producer, and it will take event tracker, fake event tracker. Okay, if we run this now, so it passes, but how would we then test its state? Test state, it would be producer, let's say change name, producer dot present, and here is our problem, because present is actually a composable function that returns a state, same as producer. We covered that already, and it has to be called from compose context. But what we will do, the same that circuit does for testing presenters, we will do molecule flow, recomposition mode. We would do exactly the same, immediate, and then we would have this called there, and then we would call test on it. And now we have another problem, that this is not a suspend function, but we will fix that easily. And right now this behaves exactly the same as the presenter that we saw. And we will do producer, await item, event sync, and let's see what is. Oh, I already said that I would. Let's change military points. Change military points, and set military points. Set military points. Military point 10. I like to import these things so it doesn't get clogged, and then we would just assert equals 10, await item, military points. Let's first see it fail. So we will have military points 0, but the initial state is 0, but it doesn't. We know it. It doesn't. Okay, and then we will have 10. And we see that it passes. Then we can also do that neat trick for producers to extract helper test extension function to make this a bit cleaner, but this is not that bad, and we don't have, for example, presenter interface to define things on it. We can create our own producer interface that we can define this extension function on, and that our producers will implement. But again, it is the same as this. It's a molecule flow, so basically the same thing. And now on to the UI tests. This you would set up UI tests as a regular Compose multi-platform UI tests. So let's just take a look at that one. It is Compose UI test. You see, it is from JetBrains with the multi-platform version. You need to set this up for Android target, and when it comes to the Android app, we actually need to enable Android JUnit test runner. That's it, and instrumentation tests dependency for Android. This is the standard way. Just follow the documentation on Kotlin multi-platform testing, and because this will probably be outdated at some point, just follow the documentation, because these are plain UI tests. We would just be testing circuit screens with it. I just wrote a boilerplate for it, but let's actually delete it now that I see. I want to explain it. First, we need to create our screen. It would be we need to set content. That's how this is the entry point for UI test composition, and we would have counter UI. We would have counter screen dot state. We need initial count for the state, and we need event sync. That is where this test event sync comes in. What is the test event sync? Received events. It just keeps, not just, but it keeps track of received events, so we can assert on them later. And we would delegate things to it. So the event that we have here is as you can see in the hint, it is counter screen dot event. And we can just quickly run this to see if it works. This is the command to run those on Android. And because I have an emulator running here, let's just do that on Android. As you can see, it passes, but let's see it fail. I always love to see them fail first. Of course, it's not asserting anything right now, so there's nothing to fail for. But I don't know, what did I do? I probably ran it as a regular test. Yeah, we can see assertion failed, assertion error. Okay, first we will assert that on the screen we have everything that we need. On node with text, we need the initial count 0. We need to assert that it is there. This is also just a regular testing for UI. And then we would have increment. And we would have decrement assert is displayed. Let's just run these to see if that will pass. Okay, we see that it passed. Let's just see it fail for something. Assert does not exist, but we know that it does, so it should fail. I always run it as a regular test. No, I also I have it here. Okay, it failed because it exists. Then we would test that the correct event is fired for the desired action. Again, we would copy this. So on a node with text, increment, perform, click. And after that, we would assert that, not like this, but we will assert that increment event was sent to event sync. So we would have event sync, that is our fake test event sync, and we would assert event increment. And we can run that right now. And I should also have it just decrement so it fails. And that is how we test that correct events are fired, but how presenter behaves and what is the behavior for each event. We do that, not run the app. We do that inside of presenter tests and presenters. This now we are just focusing on testing if everything sends events correct. Now we are just testing that everything is sending correct events. Import. Let's run this. We can also, yeah, as I figured, assert events. Not run, oh my god, muscle memory. Okay, now it passed. And that's it. We saw how to test presenters, how to test regular producers that are not circuit presenters. Again, you can take this and use it elsewhere, not just with circuit, but circuit builds nice on top of it. And we saw how circuit makes it easy to do UI tests. We just set up the screen, we have fake event sync, and then we do regular assertions and perform actions from compose UI testing. But then for verifying the correctness of the behavior of our UI, we verify if the desired events are being sent. Again, UI tests are just for that, for the actual logic and what happens on those events. We use presenter and presenter tests for that, or producer, depending on how you decompose your screen. We'll wrap it with testing right now, and see you in the next one.